Yes, children. Let us see now properties of haloarenes. Okay, we saw about properties of haloalkanes. What all we saw? Nucleophilic substitution, SN1, SN2 reactions. Okay, and then Wood's reaction, then beta elimination, then reaction with the magnesium to form Grignard reagent. Right, all these things we saw. And now we will see properties of haloarenes. Okay. Now haloalkanes are highly reactive towards nucleophilic substitution because a stronger nucleophile, if it can replace the halide ion from the alkyl halide, then it is called as nucleophilic substitution. So there are so many nucleophiles which are stronger than Cl minus or any other halide ion. So it was undergoing nucleophilic substitution, and all the more because the halogen was attached to an sp3 carbon. sp3 carbon is less electronegative, so the CX bond in haloalkanes is more polar. That is why it was possible. Now let us see what happens in the case of haloarenes. Now haloarenes are less reactive towards nucleophilic substitution. Very first line it is. Now why it is less reactive? Now look at the chlorine that is attached to the carbon of the benzene ring. This carbon, which is a double bonded carbon, is sp2 hybridized. Okay. Now sp2 carbon is less electronegative, or sp3 carbon more electronegative. Obviously sp2 is more electronegative than sp3 carbon. Okay. So this carbon is also electronegative, Cl is also electronegative. Then obviously it becomes a question that between two electronegative atoms, how can there be polarity? And apart from that, the lone pair of electron on chlorine, it gets delocalized into the benzene ring, creating negative charges at ortho and para positions. Look at this. Ortho position में negative charge, para is having negative charge, another ortho is also having negative charge. So this pair of electron is getting delocalized throughout the ring, creating negative charges. And because of that, what is happening? This CCl bond is getting a partial double bond character. Okay. Now because of the partial double bond character, you know that greater the number of bonds between any two atoms, stronger is the bond, is it not? So this will not break easily, right? So the electron pair on halogen is in conjugation with the pi electrons of the ring. Conjugation means एक छोड़ के एक. The lone pair is becoming a double bond, and then this double bond gets shifted. So what you will find that there is a double bond, then a single bond, then a double bond. So this is what is called as conjugation, a particular property alternating with each other. Now due to this, the CCl bond acquires partial double bond character, so Cl is unable to leave as Cl minus. Right? Greater the number of bonds, shorter the bond length, stronger is the bond. Now apart from that, what other reasons are there which makes haloarenes less reactive towards nucleophilic substitution? Second point, C holding Cl or any halogen for that matter is sp2 hybridized. Whereas in the case of Rx alkyl halides, carbon is sp3 hybridized. Okay. This sp2 carbon is more electronegative due to greater S character. Right? In sp3, S character is only 1 out of 4, isn't it? sp3, when you consider, and sp2. See, this is 1 plus 3, 4. Out of 4, 1 part is S. Out of 3, 1 part is S. So here, if you take the percentage, it is 33%, and here it is only 25%. So S character is 25%, which is less. CCl bond length in haloarene is 169 picometer, whereas in the case of Rx it is 177. Shorter the bond, stronger is the bond. Now apart from that, if at all, if you think that okay, Cl is leaving as Cl minus, then it will lead to a phenyl cation, is it not? A positive charge on the carbon of the benzene ring. Now that phenyl cation is not stable. If at all self-ionization of aryl halide is considered, the phenyl cation formed is not stabilized by resonance. Okay, so if agar carbocation ban jata, then SN1 reactivity possible ho jata, is it not? So that is also not possible. And apart from all that, fourth reason is because of the pi electron cloud in the benzene ring, the incoming nucleophile may face repulsion. Nucleophiles are negatively charged. And because of the pi electron cloud in the benzene ring, there is charge cloud, negative charge cloud, is it not? So this negative charge cloud and the incoming nucleophile with the negative charge, they may repel with each other. That is why they are less reactive towards nucleophilic substitution. You need to know all the 4 points properly. Even if it is for just 2 marks, you need to write briefly all the 4 points. So, if it is not undergoing nucleophilic substitution, then what is it undergoing? It is undergoing electrophilic substitution. Now, halogen present on the benzene ring is ortho-para directing. Why it is ortho-para directing? Because it is creating negative charge at ortho and para position. So, it will favor an electrophile to attach itself towards these 3 positions. Is that clear? So we see ortho and para positions getting negative charge, which will facilitate electrophilic substitution at ortho and para position. Right? Okay. So it will undergo electrophilic substitution. Now what are the different reactions? This electrophilic substitution, what all reactions do you have? Just see. If it is subjected to chlorination in the presence of anhydrous AlCl3 or FeCl3, you will get ortho-dichlorobenzene and para-dichlorobenzene. Para product is the major product because of greater symmetry. Now this is an electrophilic substitution. Here this Cl2 will react with AlCl3, giving rise to Cl plus and AlCl4 negative. That is why the incoming electrophile is Cl plus. That's why you are calling all this as electrophilic substitution. AlCl3 is a loose acid, so it will take away the chlorine along with the bond pair, and that is why it will become AlCl4 negative, right? Then with concentrated nitric acid and sulfuric acid, it will give the corresponding ortho-chloronitrobenzene and para-chloronitrobenzene. Again, para product is the major one. Now here, which is the electrophile? NO2 positive. This is the electrophile. Then in the case of concentrated sulfuric acid, it is sulfonation. This is nitration, this is sulfonation. You will get sulfonic acid group getting attached. Then if it is subjected to CH3Cl in the presence of AlCl3, this is called as Friedel-Crafts alkylation, when CH3 is attached to ortho and para position. Okay, so this is Friedel-Crafts alkylation. Now here again, CH3Cl plus AlCl3. This will give you CH3Cl plus AlCl3 will give rise to CH3 positive plus AlCl4 negative. So CH3 positive is the electrophile in this reaction. Same way, Friedel-Crafts acylation, where CH3CO positive is the electrophile. You will get the corresponding ortho and para product. Now apart from this chlorobenzene, if it is reacting with methyl chloride in the presence of sodium and dry ether, then it will give you toluene. Okay. Now this alone is not electrophilic substitution. The rest all reactions are electrophilic substitution reactions. Okay. So that is about haloarenes property. So we have seen so many conversions. I don't know how many of you are having it in your notebook. Okay. So have a quick go through of all that. So tomorrow I'm going to take a small test in the class.